Welcome to CS225. I'm your instructor, Robert McMillen, and we are on Module 7, where we're going to cover Chapter 10, Installing and Managing End-User Computers. Our chapter objectives are major site preparation steps for computer installations, pre-installation site preparation tasks, the purpose and contents of a site management notebook, tools needed, steps to install and configure hardware, common installation wrap-up tasks, and ongoing site management. System installation overview, pre-installation site preparation. You've got lots of different things to do to prepare a site for a desk nowadays for an employee. Pre-installation site preparation checklist, space requirements, constraints, things that would keep it from working the way that a user would want, special furniture that may be required, material storage requirements, ergonomic issues, ADA and OSHA accommodations or issues, that's for compliance, adequate power supply, power conditioning requirements, network telephone access, air conditioning, lighting issues, and fire suppression systems. Locating system components, locate computer systems, devise strategy to conserve space. You want to put the computer in a spot where the person's knee isn't necessarily turning the computer off all the time, or where they cannot reach the DVD tray. System components, system unit, the footprint, of course, the size of the desk that is being taken up by the computer system. Keyboard and mouse, optimal desk height is 26 to 28 inches from the floor. Display screen, optimal user view is straight ahead or slightly down. Printer, convenient access for loading paper, retrieving printouts, and clearing jams, unless you use a network printer that's in another location in the office. Supplies, you want convenient access. A tip would be to avoid storing paper in a damp area or it will stick together. Furniture considerations, the importance of an adjustable chair for different heights of people. Space saver system unit case, small form factor. Separate computer work table if necessary. Flat panel display screen. It could also be wall mounted. Monitor arm for CRT display. That allows you to articulate the monitor to be better positioned. Keyboard shelf and extender cables, which need to be hidden as best as possible. Ergonomics is the study of how to design computer systems and workspaces to minimize health problems and maximize worker safety, productivity, comfort, and job satisfaction. If you have a worker who ends up having health problems due to the way that you've set up the computer space, then you will have downtime and loss of productivity. Back or neck muscle pain, leg pain, eye strain and headaches, wrist and finger pain are all things that can happen if the ergonomics are not set up proper. Ergonomic solutions. You have ergonomic problems, back or neck muscle pain or numbness. You have different solutions such as adjusting keyboard height, installing a shelf. Leg or pain numbness, you can replace the office chair with an ergonomic model or put a footrest on the floor. Eye strain and headaches, you can reorient a computer to reduce glare, install display screen anti-glare, among other things listed here. Here's a picture of workstation ergonomics of an optimal setup. Here's the desk height recommended, the angle to the LCD, keyboard, monitor, armrest, footrest, and wrist rests, and the typical distance from the monitor to the person's eyes. Devices to address the ergonomic problems: adjustable tables, adjustable chairs, footrests, keyboard shelves, alternative ergonomic keyboards, some keyboards that possibly split in half and tilted slightly, allows carpal tunnel to be relieved. Alternative pointing devices such as a trackball. Some people cannot use mice because it hurts their wrists, so a trackball might be in order. So these concerns are important issues. They could result in injuries, permanent disabilities, and of course that could leave the company open to legal issues and fines from OSHA. So here's a tip. Ergonomics is an area where user support specialists can develop special expertise to add value to their employment or resume. So if you're able to help the company have good ergonomics, then you will be more valuable to that company. Most small computer systems do not have special electrical power needs, but sometimes there are some special situations. Two-prong outlets, incorrect outlet wiring, overloaded circuits, shared circuits, which tend to cause overloads, power stability, multiple computers, and something that a lot of people are doing nowadays in winter is they're plugging in heaters into the same power strip that the computers are in, and they're all confused as to why their computer isn't working properly. Outlets in older buildings may only have two-pronged outlets. It might have to be rewired. You have to use an outlet tester. Test the three-prong outlets. Make sure that they're all wired correctly. Sometimes low-end power strips have some of the wires backwards, and a tester will help make sure that those wires are in correctly before you plug in your computers. Amperage determines the total amperage of devices. Can the circuit handle the total load? You want to make sure that you add all that up before you plug everything in. Sometimes you have shared circuits, which can definitely overload that particular system. Power stability. Get advice from the local electric utility. Use a metering device to measure the quality of power. Power conditioners, which are built into UPSs, is a device between the computer and the power source that regulates electrical power to keep it within acceptable limits. That keeps the computer equipment from shorting out or having a shorter lifespan. Problems with multiple computers, especially for servers and high-end workstations, you want to consult an electrical contractor to make sure everything is done correctly. You want to avoid stressed cables. You don't want to pull those cables too tight because those have little tiny copper wires inside that can snap if that's the case, or have any hard bends in them. You want to avoid cables under the floor or carpet. You want to use wall-mounted cable conduits or runways. Those are good. Protective rubber conduits and plastic cable ties to bundle the cables together. You want to use an electrical power strip for convenience, but not as an extension cord. Don't string a whole bunch of power strips together. You want to have a surge suppressor, a protective device to reduce damage to equipment due to power surges and spikes. Minimum surge suppression. These are lower cost ones, lower cost than power conditioners. These are alternatives to power conditioners. So you've got the various different specs here for minimum surge suppression. The ones you get at the hardware store are not going to be adequate for computers. You need to get one that has better specs as shown here. Some environments have critical power needs to reduce downtime and increase uptime. Downtime, the number or percentage of hours or minutes per week or month when the system is unavailable. That means lost productivity. Uptime is how long it's up. Examples would be a hospital critical care unit or an online financial transaction processing system. A UPS is an electrical device that includes power conditioning circuits, it's already built in, and a battery backup in case there is a loss of power. A UPS provides backup power in time for computer equipment to be shut down correctly. You can install the software that comes with the UPS to automatically sense and shut down a server that has lost power. Determine the location of access points before installation in case extension cables are needed to reach the installation site. So especially for these wireless access points, you want to make sure when you plug them in, if they're not power over Ethernet, that they have that kind of thing. Identify the type of network access. You have dial-up, which of course is much less in use nowadays. DSL, also lowered in use. Cable modem for broadband service, it tends to be growing. Satellite now has much faster speed and is a good type of ISP in a rural area. T1 or T3 direct lines are just a bunch of cables from phone lines that are all wrapped together. They tend to be a lot more expensive but very stable, and of course wireless. Air conditioning may be required in locations where a large number of computer systems will be installed in close proximity. You may want to also have a monitor that says when the air conditioning cuts out, so you can be emailed before the temperature gets too high and causes computer damage. Lighting problems. Light intensity. Reduce lighting in overlit areas. That would be for the areas that people are working. Don't want to have a humming or overlit, making it difficult to see the screen. The light source you want to position to avoid glare. Users should not face light source directly. Light type, fluorescent bulbs may flicker at the same rate as CRT type monitors. So you want to make sure that fluorescent bulbs that you put in are high enough quality that don't cause flickering, which could cause issues for the users. Electromechanical equipment is more likely to cause fires than electronic devices because of the moving parts and the power supply problems. If an office does not have an existing fire suppression system, you want to use portable fire extinguishers rated for electrical fires, which is a Class C, or use halon substitute extinguishers. And you want to make sure that if it's in an enclosed room that you get out of the area before all the oxygen is depleted from these halon substitutes. A site management notebook consolidates important information about a computer system. This is good for documentation. You can document hardware, operating systems, software, and the network. They are useful to operate, diagnose, troubleshoot, reconfigure, upgrade, and repair a system and its components. They are critical in multiple computer situations where many support staff are likely to work on a variety of components and configurations. So you want to document all that information. Typical contents of a notebook would be hardware configs, operating system configs, network software licenses, application software configuration. Once you install the software, it may be specialized in its configuration. Special operating procedures, warranty and repair information, problem log, and backup media log. This log will likely be electronic and not physical, not on paper. Example checklist from a site management notebook. Desk, printer stand, LCD projector, all these different types of furniture and supplies and accessories that you would use when setting up a site. Hardware installation tools, make sure that you always have a couple of different types of screwdrivers, nut drivers, pliers, and parts pickers for when screws get lost inside a computer. Additional hardware installation tools, things like a knife, small parts containers, mirrors, flashlights. Lint-free cloth is very good. Circuit testers can be helpful. Cable ties and things like that. Here's an example of what a toolkit would look like. Common hardware installation steps. You've got to follow the guidelines for working inside a system in Figure 10.7. Major hardware installation steps would be to assemble the toolkit, unpack the system, connect the power, install upgrades, power everything up, test it out, and update the notebook. Make backup copies of existing system and user data, install and configure operating system software, device drivers. These are all steps in setting up a network installation. Install and configure network software. That's on the operating system itself. Test the connectivity, make sure you can get out to the internet, make sure you can get to the servers, the mail servers, all those different things. Perform network administrative tasks, user accounts, access rights, and once again, update the notebook. Typical steps for application software. Is the software compatible with the hardware and the network? Make backup copies. Choose the type of installation. Configure the application to meet user needs. Install organization-specific utilities, templates, and style sheets. Reboot and test all those applications and retain in the notebook. Make sure you have the license information. Compatibility issues, CPU types the software runs on, space requirements, got to have good RAM, good hardware for the software requirements, software compatibility with hardware peripherals, the user's network environment, and of course other applications. Distribution media that contains the original vendor copies on CDs, DVDs, or internet downloads. You want to make sure you have these off-site in case there's a fire. Don't install software by copying its image from another computer. Registry and startup files don't get updated. Installation types, you've got Express, which is typical or common. The most commonly used features you can put into a file so it automatically installs the way you want it. Custom, and that could be a special or expert installation, minimal installation, or a full installation where everything is installed. Wrap up tasks after the installation. You've got to document the settings, back up the critical files, create rescue disks in order to be able to restore more easily. Those no longer come with computers, so you have to create them yourself. Address ergonomic concerns, of course. Make sure the user can use the system. Update the site management notebook. Fill out the warranty, document any problems, and verify that the user is satisfied. Site management responsibilities, you want to do the media backup like we talked about, monitor for potential security threats, disaster, and contingency planning is important. Other site management activities include preventive maintenance, computer supplies, recycling computers, and peripherals. Of all those, preventive maintenance is one of the most important because it allows the computer to run better and longer and makes the user of that computer much happier. Some preventative maintenance might be disk defragmentation, disk scanning, and other utilities. Media backup copies files and folders of software and data from a PC's hard disk onto a separate storage medium. That could be on tape, which is becoming less popular, or hard drive or DVD. So there's lots of different ways. You can also have it off-site. You want to rotate that media. A hard drive on a network server, like I mentioned, tapes, CD, DVDs, etc. And of course you want to test the file restoration to make sure it works. A lot of times we see people think they're backing things up and they are actually not. Sources of security threats. Electronic threats arise from attempts to breach information. Physical threats arise from attempts to damage or disrupt equipment or facilities. Sometimes we get hired to do white hat hacking, and sometimes they're electronic threats where we try to hack into the servers, but other times we just walk into the office and pretend that we're workers just to see how long we can go before someone will stop us. Internal threats arise from inside an organization. There's a bigger threat from employees than there is from outside the organization. So you want to make sure that the network is safe against employees from doing things accidental or on purpose. There are viruses, worms, Trojan horses, which we generally call malware or malicious software, spam and email attacks, unauthorized access, operating system vulnerabilities, spyware, insecure data transmissions where you send things in clear text that can be intercepted, tools, password protection, anti-malware software, firewalls, utility software, and callback modems. More physical threats to security. You've got theft of the actual equipment, disgruntled employees who feel that they're entitled to something on their way out, members of the public who are threatened by technology and bureaucracies. Some security tools, you've got keypad entry locks. These are physical security tools, ID badges and cards, biometric readers. All different types are out there now. Motion sensors, camera systems, reception desks, metal detectors, and physical barriers. So sometimes the best physical security tools are pretty basic, such as physical barriers, walls and windows, or a receptionist. Disaster and contingency planning should be done by everybody. Every company should have a disaster and contingency plan. Lots of different sources for disasters. And you have to have risk management, which are tools and strategies to reduce the threat to an organization from unpredictable, uncontrollable disasters and accidents. And you run through these different strategies in a contingency plan. And you decide how much money you're going to spend as a company on how much downtime versus the cost of being back up as soon as possible. Some companies choose to never go down and pay a large amount to have that happen, and others are okay with being down for 24 to 48 hours and aren't as concerned. They just want to make sure they have a decent backup. So you've got business interruption insurance, which you can get now to offset the cost to return to normal operation. Engineering inspection, media backups, of course, which can be on-site or off-site. And the disaster contingency plan, which is a plan written down, handed off to all stakeholders in a company, and then practiced. Preventative maintenance is something we believe in very strongly. There are tools and procedures to reduce the likelihood of computer component failure and repair costs. Procedures to clean and adjust system units, disk drives, printers, keyboards, mice, and display screens can go a long way to keep your computers running properly and not being overheated. System units, remove dust buildup with a vacuum cleaner. Make sure you're not touching the motherboards when you are vacuuming. Test electronic components, battery strength, and the internal-external cable connections. Disk drives serviced only by a qualified technician, usually replaced rather than repaired. Printers, remove dust and paper particles with a vacuum cleaner. Keep the inside free of ink and toner spills. Otherwise, you end up with a long scratch or some other thing that can happen when you print. Keyboards, you want to remove the dust using compressed air. So sometimes you want to suck up the dust, sometimes you want to blow the dust out. In this case, with keyboards, you want to blow it out. You've got mouse and trackball parts. You want to clean the rubber ball and contacts, although very few people are using that anymore. Display screens, you want to keep the screens clean and use the proper cleaners so that the screens don't get damaged. Maintain an inventory of printer supplies, media cleaning supplies, replacement parts, so you can fix things and clean them quickly. You don't want to have to wait for a replacement before you go out. Sources could be the local supply, office supply, and you can also go online as well. Managing recycling of computers. This is an important thing. There are state and federal laws that keep you from throwing things in landfills anymore. You can dispose of them by handing them down to other people. You can donate them or use a responsible recycler. Some supplies cannot be recycled, however. So in this chapter, we talked about basic steps to install a computer system, site preparation for computer installations, site management notebook, hardware installers, installer checklists. Ultimate measure of installation success is the user satisfied. And that will do it for Chapter 7 and Module 7.